Welcome to section 7.1 and 7.2. We are going to work on what we call one-step and two-step equations. Now, you are going to find that I have slides that have a series of steps based upon the type of equation we're going to work with. Now, my recommendation is that you print out these slides or take very good notes so that you can find and complete the equations that we're going to be working with. Now, our first slide is going to talk about the process of adding and subtracting. And this is going to be what we call the one-step process. Now, step one, we are going to find the side that the variable's on. That is the start. Where is my variable? Then we're going to do something called a block method. Now, some people have other methods, but I find that I like the block method better than others. And the process of how we do it is in these next 3 steps. Now, the key is the variable is staying on the side that you find it in step 1. Then you're going to look for a number that's on the side of the variable, and you are going to do the opposite. So if we see a subtraction sign, or if you are adding, we're going to subtract, which is the opposite of adding. If we see subtract, we're going to do the opposite. We're going to add. And the key is when we come to the end, we are going to have a positive variable. And that is going to give us the answer that we need. Now, again, you can print these out, but sometimes it's always better to show you than it is to write out these 4 steps. Now, first off, step number 1, okay? We are going to find the variable. Okay, the variable is right here. That variable is not moving. Then we're going to do something called the block method. Okay. First is variable. Then we do the block, which means I'm drawing a line here. Now notice I left a space between the equation, and what I'm going to do is I'm going to bring down below that bar an X, because that X is not changing. Now, what is happening with the 5? Well, we're adding 5 to that X, which means above the line, I am going to subtract 5 from both sides. Now, the reason for that is I want to get this X, which I brought down in the block method below the bar, by itself, because a positive and a negative number are going to cancel out. Now, we're going to finish by going to the right side. I have a positive 20 and I have a negative 5. This will give me a positive 15. Now, since my X is positive, my answer for X is 15. Now, I'm going to do something on this slide that I'm not going to do on a lot of them, but your book sometimes asks you to check this. Well, that means where that yellow X is, I'm going to put 15, plus 5, and I want to see, does that equal 20? This 15 is my x, and this is what the check is. I replace the variable with the number I got. And as you see, 15 plus 5 does equal 20. Now, do I need to check every one of these? Well, that's your choice. But I'm showing you when they talk about checking it, it means taking your answer, going back to the original equation, replacing that variable that didn't move with the rest of the equation and seeing if it is true. Now, our next equation. Okay, first thing, find the variable. That's right there with x. Well, I'm drawing a line. Now notice there is a space here. So in notebook land, I have x minus 4 on one line of my notebook paper, and I'm going to skip and right below this line, I'm going to write x. Now I'm going to do the opposite. This is a negative, so I'm going to add 4 to both sides. Well, as you see, these 4s are going to give me 0. Well, I'm not writing 0 next to my x, but I am going to the other side, and I have a negative 23 and a positive 4, and this will give me a negative 19. Now, remember, if I want to check it, where that yellow X is, I'm putting negative 19 minus 4 is equal to negative 23. This checks. Okay. Now, we're going to get a little more interesting here. Okay, this one starts out a little differently because the first thing you're going to have to do is combine terms. We're not going to bring down the x yet because I have two x's. Well, the first thing I'm going to do is a positive 8 and a negative 9 is going to give me a negative 1. Now, these two x's are going together. This is going to give me a positive 3x, and a negative 2x is giving me a positive 1x. And then I have this single 4. I have to combine terms first. Now notice, I did not cross the equal sign. When you combine terms, because you have more than one x or more than one number on a side, we are combining terms. Now, we go back to what we've did in the previous slide. I'm going to draw the bar. This time, the x happens to be on the right-hand side of the equal sign. I'm still bringing it down, but that negative 4 is with the x. I'm not moving 1. I'm moving the 4, which means I'm doing the opposite, which means I'm adding 4 to both sides. This is going to cancel. And notice my red X is on the right side and it's all by itself. But I have a positive 4 and a negative 1, which is giving me a positive 3. This is my answer. Okay. Now, this is what we call one step for the addition and subtraction property. But we also have a one step for multiplication. Notice we're going to find the variable first. That's most important. Now, we're going to do something a little differently than how we did it with the block, okay? We are going to be using what they call the fraction bar. And remember, to solve an equation, you are doing the opposite operation. And we're going to show you that, okay? And since we are multiplying the coefficient and the variable, that fraction bar means we're doing the opposite. We are going to be dividing, and it's the variable side that's going to be the indication that I'm dividing. Now, let me show you. Okay, first off, where is the variable? It's right here. Now, what puts the 5 and the x together? Multiplication. What's the opposite? The opposite is to divide, which means I'm using the fraction bar. That's what this is called. It's the fraction bar. And notice I put it right below each term on both sides. But what's going in the denominator below that fraction bar? It is always going to be the number that's with the variable, because we want to cancel these 5's out. 5 divided by 5 is 1, and mathematicians don't like to write that 1. So we have x all by itself. Now, over here, the bar means divide, which is right here. So our x is 4. Now, to check this type of equation, it is going to be 5. Now, we're putting a parenthesis behind 5 because that's where the x is. And then inside the parentheses, we are going to put that lovely 4. 5 times 4 is equal to 20. Okay. Now, we're going to try it a little differently. Okay, where is the x? X is right here. That x does not move, which means when we finish, our x is going to be on the right-hand side of the equation. But the number -3 is attached to the x. That is what's going below the fraction bar. Okay? Now, the beautiful part is when you have a -3 and a -3, if you remember when you multiply, it's going to give us a positive 1x. Now, on this side, we have a single negative number. So 15 divided by -3 is -5. This is our answer. And again, I always like to show you a check on a couple of slides because Pearson does sometimes ask you to check it. Now, this means I would write 15 equals, now -3 is getting a parentheses behind it, and it is in that parentheses I'm putting -5. times negative gives me a positive 15. It checks out. Okay. Now, there are occasions when you're going to see a variable right here, but notice it has a negative in front of it. Now, that's really saying I have a negative 1x is equal to 49. This x right here, when I finish, has got to be positive, which means I am dividing both sides because I have to get rid of this negative in front of the x, but I have to know a 1 is sitting there. And remember, mathematicians don't like to write ones. So this will give me x, but over here, x is a negative 49. And if you remember, and I'm going to show you with the check, we have the negative sign, a parentheses is equal to 49. Put in right here my negative 49, negative, negative makes a positive. Okay. Now, this one again. Okay, all you're told is solve, but before you can begin, the first step is you have to combine terms. Now, why do I have to combine terms? Because if you look at this side, the left side, we happen to have two numbers. This will give us a negative 6 equaled x. But now I've got to put these two together. Well, if you remember, this is a negative 2 plus, now 3 squared is 9. That means this is a positive 7. That's how I get a single number. Now this is back to our addition and subtraction rules. We are going to draw this line. This x is coming down. It is the 7 that's moving. We are subtracting 7 from both sides. This is going to cancel, but be aware, a negative plus a negative is going to give us a negative 13. That is our answer. Okay. Now, please don't move the negative 6. If you move that negative 6, you're going to empty the left-hand side. We can't do that. Letters have got to be on one side of the equal sign, numbers on the other. Letters do not move if they are by themselves. They're staying. Okay. Now, let's look at this one. Okay. First step we want to do is to combine terms. Now, first off, see this equal sign? Negative 66 is all by itself. It's not moving. We are combining these two terms. Now, 4 next to negative 2 means I have a negative 8x and a negative 3x. When I combine them, I'm adding and I get a negative 11x is equal to a negative 66. I'm going to divide, okay? this will give me a negative 11, because remember, we want this x to come out to be positive. This is going to cancel. Negative 11 divided by negative 11 is a positive 1. I'm not writing positive 1. 1 is understood, but don't forget here, a negative divided by a negative gives me a positive number, which is 6. Now, again, first step, combine terms. Now, how do you know that you have to combine terms? Well, first off, this right side is all by itself. But look at what's on the left side. We happen to have 2 x's, which means I've got to combine them in some way, shape, or form based upon order of operations. Well, this is going to give me 6x plus 9x. Now I'm adding 9 and 6 to get 15x. This is equal to 45. This one number isn't moving, it's staying. Do not move it, okay? Because now, to finish the problem, 15 is next to x, which means multiply. But to get rid of the 15, I do the opposite. This 15 and this 15 is going to cancel, leaving the x. But the bar says divide. That is my answer. Okay. Now, this is the one-step process that we've talked about for add, subtract, and multiply. But we have one more one-step process, and that is for division. Now, this is where you're going to have to be a little careful with what we have. Now, again, we're still finding where the variable is. And this is where we're going to have to check to see, are we going to have to combine terms? We might not. But this is the different part. You have 2 steps here to think about. Will the variable appear in the numerator of a fraction, or is it going to appear behind a fraction? This involves fractions. Now, if it appears in the numerator or it appears behind, this is what we're going to do. We're going to multiply both sides by the reciprocal of the fraction. And remember, I need a positive variable in the end. If you need to write these down or you need to print these out, keep these steps. They help you. Okay? But I'm going to show you what I mean. Okay, this time, notice my x is the numerator of a fraction. I also have these 2 numbers on one side. Well, first off, these 2 numbers are going to equal -4 because I had to combine terms. But when I write this fraction, I write it as 1/5, and I put the x behind. Do you see I put the x behind right here? Now, remember it says I'm going to use the reciprocal? Well, that means I'm going to multiply 5 over 1 here, and I'm multiplying 5 over 1 here. Now notice I'm going to put a 1 underneath the 4 because I have to create fractions. And also, if you remember, you're saying, but why, if 1, 5 is next to x, that means multiply. Why am I using the reciprocal? Because, let me show you over here. If I have 1/5 x, basically what I'm doing is dividing by 1/5 x. This fraction is dividing itself. But what happens, this line is saying I'm using the reciprocal. A fraction, when you divide it, if you remember, we use the reciprocal. Okay? This is what we call a complex fraction, a fraction divided by a fraction, and we've seen that. Well, now, when we're solving equations, we're basically using the reason for this fraction bar. The fraction bar, which is right here, is saying I'm dividing. So this 5 and this 5, and nicely but neatly, this 1 and this 1 is leaving me with x. Now remember, we're multiplying. Now, this 1 and this 1 could be the bottom of my fraction. The number is -20. But as you remember, mathematicians don't write the 1 when it's in the bottom. So my answer is x equals -20. This 1 is understood. Mathematicians don't like to write 1s. So technically, this 1 and this 1 are understood behind the -4 and 5. Okay? Now, let me try it again. Okay, now this one's a little different. Okay? I have the a already behind the fraction. But don't forget, over here I have 2 numbers. I need to combine terms. Now, that doesn't mean I'm changing signs. I'm combining terms. This is going to be 25 plus 2, which is going to give me 27. And I have this 3/4 and the a. Well, remember, this a is not moving. I am going to multiply by the reciprocal, which is 4 over 3 here. Now, this one's going to be a little different. This is going to give me my a. Because if you cross multiply, I have the number 1 appearing in front of a. But over here, this 3 and this 27 are going to cross cancel. Well, notice now, I got 2 1s in the bottom. Take the numerators. 9 times 4 is 36. Now, do I need to put the 1 under the 36? No. These 1s are understood to underneath the 36. Okay? Now, those are all step equations. I get the variable on one side, I get a single number on the other side. Now, I may have to do some combining of terms to make that happen, but one combined term in good shape. Now, in 7.2, we introduce you to the two-step process. Now, again, we're going to find the variable. The variable is not going to move except if I have more than one variable. And I'm going to have to show you that in a minute. Okay. Then we're going to add or subtract first. That's the catch. We add or subtract the number is not leaving. Coefficient. Those one steps that we bring them together, but do the numbers. Then occasionally we're going to be dealing with the distributive property, but we're going to talk more about that when we go to 7.3. But I want to introduce you to that. Okay, here we go. First step. Variable. Where is it? Well, it happens to be right here behind the 7. Now, this is where we go to the block. We're going to draw this line here. Now, this entire term is coming down here, 7x. Now, my third step is I'm subtracting 1 from both sides. -1, -1. Now, as you see right here, positive and -1 behind the 7x cancel. They're gone. But on the right-hand side of the equation, I get 35. Now, my fourth step is to divide by 7. Why am I dividing? Because 7 is next to x. This 7 is here, this 7's here. X is equal to 5. And that is my answer. Variable. The block means I've got my bar. I'm subtracting 1. And then I'm dividing. Okay. So I add or subtract first. Then I multiply or divide. Let's try this one. 1. Variable. Well, the variable is right here. Okay. I'm then going to bring this entire term down here. This is 3x. Okay. So we're working with what we call the block method. I like block better than what we call horizontal because you can see what you're doing and you make nice, neat columns. Now, this time we are subtracting 1 from 3x. So therefore, this time we are going to add 1 to both sides. I'm adding 1 here. I'm adding 1 here. Well, as you see, this negative and this positive are going to cancel. Now, I'm going to come over here and get 23. Well, my fourth step is to divide by 3. Well, I'm going to divide by 3. Now, this is x. Now, 23 over 3. Okay? This is a good answer. You don't want to divide it out, but if you have to reduce, you got to reduce. In algebra, this is known as an improper answer. It's a fraction answer. We don't make it a mixed number. It stays as it is. Okay? So as you see, some answers we get whole numbers. Some answers we are going to get improper fractions. Improper are fine as long as I cannot reduce. Okay? Improper fractions are good if I don't have to reduce. This does not mean make my answer a mixed number. It stays as an improper fraction. Not a mixed number. I can only reduce it. I don't want to make it a mixed number. Okay. Now, let's look at this one. Okay. Well, first off, we are going to find the x, which is right here. Okay. So my first step was variable. Now, my second step is the block, which means I'm drawing this line and this term, negative 4x, is glowing below the bar. Now, my next step will be, this is adding to a negative 4. So I am going to subtract 2 from both sides. Now, as you see, positive 2 and negative 2 are canceling behind the negative 4. Now, this is going to give me a positive 36. Now, my last step is I'm going to divide by negative 4. And why do I divide by negative 4? Because this x has got to end up being positive. And this will give me negative 9. Huh? Now, so far we've done 4 steps, but we're going to make life a little interesting here. Because before we begin, notice I have a single number 56, but I have 2 x's on the left-hand side. So the first thing I'm going to do is combine terms. Negative 4x and positive 9x is giving me a positive 5x plus 6 is equal to 56. The first step I'm doing, because I have two x's on the left-hand side of my equation, is I've got to combine them. Now notice, I didn't change signs of the 9 to the 4. They're on the same side. Now, step number 2. The variable. Well, as you see, I have only one x. So this brings me to the block. This 5x term is coming down. My next step, this 6 is adding to 5x. So I'm going to subtract 6 from both sides. Well, as you see, positive 6 and negative 6 are going to cancel. They make 0. I don't write 0. But this side gives me a positive 50. To finish this equation, I am dividing by 5. And this is giving me a positive x is equal to 10. Okay. Now, this slide here is when we have many variables on both sides of the equation. Okay, this is where you're going to have to be real careful. Okay, first off, we're still going to see if we have to combine terms. We've been doing that. But notice when we combine terms, we do not change signs. Now, the key is we want the variable term, if it's on the right-hand side and the left-hand side, we want to move it to the left. Move to left. But then we want to take the number and move it to the right. Okay. And then we're going to multiply or divide. Now, the key is the variable is going to be on the left. The answer or your number is going to be on the right. Now, this may not make sense until we do it a couple of times or I show you. Now, these are my last 3 slides. Okay, first off, notice right away I have a variable on the left side and the right side. I have 2 variables. Can't have 2 variables, but I have one number. Well, the one number is staying, and don't lose its sign, but this time I'm subtracting so that this number, 49, is all by itself. which gives me 7x. This variable went to the left. Now, don't move the 49. It's all by itself. It's a single number. Now, how do I finish? Divide by 7. X is equal to 7. Now, just so you understand, 1, move 9x to the left by subtracting. That's what we did on this second line. Then we divide by 7. Okay. Now, the last two get a little complicated. Okay. Now, first off, here's the equal sign. Now, notice right here, I have this x and this x. These two terms must combine. Okay. Now, this will give me 10x plus 5 minus 6x. Now notice, this is the left-hand side of my equation. I'm not looking on the right-hand side just yet. I am going to put this term and this term together to give me 4x plus 5. Notice on the left-hand side, I have only one x term, and I have a number. Now, on the right side, I have two x's. This is going to give me 2x minus 17. Okay. This x is moving to the left. So what we're going to do is subtract 2x from both sides. This is going to go here. Over here, I have positive 2x plus 5 is a negative 17. I'm going to add, nope, I'm going to do the opposite. Okay. Now, let's see. There we go. Now, I'm going to introduce a slide here because I'm writing too big. Okay. Okay. Now we have this equation. The first thing I'm going to do is I'm going to go to my next slide and I'm going to rewrite this equation. So right here, I have 2x plus 5 is equal to negative 17. Okay. Here's my x. This entire term is coming down below the bar. But this 5, I am subtracting 5 from both sides. This positive and negative is going to cancel. That's a 0. I don't write 0 behind 2x. But over here, I have negative 22. I am going to divide by 2. And x is equal to negative 11. Okay? So let me go back here. Okay. In this case, combine terms on left side. That's number one. Then, number two, combine terms on right side. Okay. Okay. That's what we did here. Combine terms on the left was what we did here. Combine terms on the right is what we did here. Then what I'm doing is step 3. Get the variable to the left-hand side of this equation. That's why we subtracted negative 2x. This was this line. We subtracted 2. Then our next step was where is the variable? It just happened to be on the left-hand side. That is step number 4. Number 5, subtract 5 from both sides. Divide by 2. And that was our 6th step. Okay. Where was our variable? Right here. Subtract 5. And then we finished by dividing by 2. Lots of steps to do, and the order matters. Now we've got one more to do, and this one's really good. Okay, right here. See this equal sign? This is the left side. This is the right side. Okay, we're going to work with the left side first. Okay? Work on the left side to combine terms. That is our first step. Okay? So what we have is right here, and these two numbers. Okay, what we have is 3x minus 2 plus 12x plus 20. Okay. This term and this term make 15x. Negative 2, positive 20 give me a positive 18. All of this is from step 1. Okay, now work to combine terms on the right side of the equation. Okay. That's what we're going to do next. Okay, well, right here. And I'm going to write this in blue. We've got to take all of this and combine it. Well, I'm going to come down here and write -4 minus 3x plus. Now, in this parentheses, this is 16 minus 1. Now, I only have 1x, -3x. But this term and this term, -4 plus 15, is how I get the positive 11. I'm working to combine terms. Okay. Now, I got x's on both sides. So what I'm going to do is add 3x to both sides. Okay. Well, here we go. I'm adding 3x to both sides. Now this is going to cancel. Now I can draw a line all the way across, or I can just draw it under the 15 and the 3x. This gives me 18x plus 18 is equal to 11. 11 is all by itself. So therefore, I probably am going to need another slide. Okay. Now, I'm going to take this equation, and you're going to say, which one? This one that I'm circling in black, and I'm going to write it on the next slide. This gives me 18x plus 18 is equal to 11. Okay. Now, here's a single x. That means this term, 18x, is coming right here. I am going to subtract 18 from both sides. Now notice these are canceling out. They give me 0. Now this gives me a -7. I still have to divide by 18 because I want this x all by itself. These 18s make 1. I don't need to write the 1. Now, this is a -7/18. This is a proper fraction. I can't do anything with it except reduce. And -7 is prime. So that means I'm going to stop. So just to make sure, I give you the rest of the steps. Okay. Number 4, variable stays on the left side. Number 5, subtract 18. And then step number 6, divide by 18 to get a proper fraction which cannot be reduced. Huh? And that's the only thing I can do with a fraction. It cannot be reduced. So these are our steps. And hopefully 7.1 and 7.2 you are going to find very easy.